Welcome to Study Loop.
In this question, we have interference from two slits, which are 0.530 nanometers apart, and the light incident on them has a wavelength of 580 nanometers. We want to look at the interference pattern. Now, for the first case, the width of the slits is really small, which means the diffraction pattern will have no change. The intensity pattern will be constant, and we only need to consider the interference pattern. We know that for just interference, the intensity varies as I naught cos square phi by 2, where phi is equal to 2 pi by lambda d sine theta, where theta is the angle that the point makes from the center. Now, for maximas, we want phi by 2 to be pi and 2 pi. Cos pi will be -1 and cos 2 pi will be 1, and that will be the maximum value for cos square phi by 2. For this, we want phi to be 2 pi, which means 2 pi is equal to 2 pi by lambda d sine theta. And for the second case, we want 4 pi is equal to 2 pi by lambda d sine theta, giving us sine theta is equal to lambda by d, and sine theta is equal to 2 lambda by d. Now, solving these equations is pretty easy. Here, theta is equal to sine inverse of, we know that the wavelength is 580 nanometers. I'm sorry, this is millimeters. This is 0.530 millimeters. So that's 580 times 10 power minus 9. And the distance d is 0.530 into 10 power minus 3. This turns out to be 1.094 into 10 power minus 3 radians. And for the second case, this same angle turns out to be sine inverse of 2 times lambda by d, which turns out to be 2.188 into 10 power minus 3 radians. Now we can obviously leave this in radians, but it will make better sense if we convert it into degrees. And that turns out to be 0.063 degrees. And for this case, it turns out to be 0.121 degrees. Now, for part B, we have diffraction in the and the intensity now changes as cos square phi by 2 times sine beta by 2 by beta by 2 whole squared, where beta is equal to 2 pi by lambda a sine theta, where a is the width of the slit. Now that we know this, we simply substitute the last values. So in this case, so in the first case, let's call this theta 1 and let's call this theta 2. Now that we have this, for theta 1, the intensity is simply I naught cos square phi 1 by 2 sine beta 1 by 2 by beta 1 by 2 whole square, where beta 1 is equal to 2 pi by lambda A sine theta 1. Now we can use a simple trick here. Multiply and divide by d, which gives us A by d times 2 pi by lambda d sine theta 1. We just found 2 pi by lambda d sine theta 1, so we can simply use that. At theta 1, this angle, which is phi, if you can remember, 2 pi by lambda d sine theta 1 is phi. So in the first case, it was 2 pi. So we know that this is simply 2 pi. And this gives us A by d 2 pi. So we know that we know the value of A and we know the value of d, and we simply substitute that into the sine theta, and that gives us sine beta by 2 by beta by 2 whole square is equal to 0.249. Notice that this is 1 because phi 1 is just 2 pi. So for the first case, at the first maxima, the intensity will be I naught times 0.249. Similarly, using the same trick for the second case, where beta 2 is equal to A by d times phi 2, which is 4 pi, we can find out that I is equal to I naught times 0.0256.